Hello students, I decided to do this video so that we could review a little bit more for tomorrow's exam. So I'm just going to go over these real quick. Just going to go over one problem per each one of the topics that will be assessed. So the first one is isosceles triangles, and so I'm going to go ahead and complete problem 2. So looking at this problem 2, like I mentioned before in class, right, anytime you have an isosceles triangle, it would be a triangle that has two congruent sides. So here we notice that we have two congruent sides in this triangle, so this must be an isosceles triangle. In the isosceles triangle, we said that the legs are going to be the ones that have congruent sides, and then the opposite angle to them will be the base angles, and those angles will be congruent. Okay, so again, base angles are congruent. So here, if I were to redraw my triangle, right, I notice these are my two legs. This is my vertex angle, and then this is X. And I recall that this angle right here must also be X because that's my base angle. So I gotta find what my base angle will be. So I gotta recall the triangle angle sum theorem, and I need to set up the equation X plus 80 equals 180. Because the sum of the three interior angles in a triangle add up to 180. So this is going to give me 2x plus 80 gives me 180. Then we subtract 80, and we get 2x equals 100. Divide by 2, and we get x equals 50. So that will be the answer for the measure of my base angle x. And that's how you solve those type of problems. I'm going to move on with problem 7. And in problem 7 says, the side of an isosceles triangle have the legs of 2x plus 4 and x plus 8. The base has the length of 5x minus 2. What is the length of the leg? So they're telling you that this is an isosceles triangle. So once again, we're going to redraw an isosceles triangle, recalling that an isosceles triangle have two sides that are equal. They're saying the base, which is the side that is not congruent, will be 5x minus 2. So this side right here is 5x minus 2. The other two sides, one is 2x plus 4, and the other one is x plus 8. Here we know that the sides that are congruent will be called my legs, right? Or the legs of the triangle. So here, in order for us to solve for x, we need to set up an equation. And the two expressions that we must set equals to each other are those expressions that are representing the legs. So we're going to do 2x plus 4 equals x plus 8. I'm going to go ahead and subtract. And we're going to get x plus 4 equals 8. So we subtract 4 from both sides, and we get x equals 4. Here, they're not asking me just for the value of x. They were asking me for the length of one of the legs. So don't forget that you gotta come back and substitute. Okay, so here if I do 4 plus 8, I'm going to be getting 12 for my leg. Or the leg, not mine, right? The leg of the isosceles triangle. All right, so that's how you do those type of problems. Now moving on, the next topic that I wanted to review with you guys is congruent triangles. So here it says that if triangle DEF is congruent to triangle JKL, and DE is 8x plus 4, and JK is 9x minus 8, find the length of DE and JK. Well, here they're telling you that these triangles are going to be congruent. And because they are congruent, then we know that the corresponding sides and angles are congruent, are equal, right? So here, if I'm giving DE right here, and I'm giving JK, I notice that they are in the same order in my congruency statement. And so I notice that these are two sides that will be congruent. So if I want to find the length of them, I gotta set them equal to each other to solve for x. And then I gotta solve for x to come back later and substitute into any of these expressions to find the length for these sides. So notice that in this equation, you have x on both sides of the equal sign. So you're going to move the smallest x term. And you get 4 equals x minus 8 plus 8 plus 8. And then you get x equals 12. But again, we're not done there because we got to come back and substitute. So DE is 8. DE is 8 times 12. I'm going to replace the x with its value, 12, plus 4. So here what we do is we substituted that value, that x value, and we get 8 times 12 plus 4, and it'll give us 100. So if DE is 100, then JK is going to be 100 because we said that these were congruent. Okay, so we do that for congruent triangles when we are giving the two sides, and if they land on the same order in the congruency statement, we set them equals to each other because they're corresponding congruent sides. But we do the exactly same thing for the angles. Okay, so looking at problem 15, now we're dealing with angles, right? They're saying if triangle XYZ is congruent to triangle MNO, and y is congruent to 10x plus 15, and n is congruent to 7x plus 30, then find the measure of angle y and find the measure of angle n. So once again, y and n land on the same position. They're in the same order in this congruency statement. So that tells me that these angles will be equal. They're corresponding to each other, and therefore they have the exactly same measure. So I gotta solve for x first by setting these two expressions equal to each other. Right? So we move the smallest x term. Cancel the smallest x term. So this is 3x plus 5 equals 30. Get rid of the constant. So minus 5. Okay, this was a 15. Sorry about that. So this is going to be 15. And then when you divide by 3, you get that x is going to be 5. Again, you're not done with this problem because the question is asking you to find the value of angle y. So you got to come back and substitute the x value. So 10 times 5 plus 15. 10 times 5 is 50 plus 15 is 65. And because angle n is congruent to angle y, we know that angle n is also 65. So that's it for congruent triangles. Very important that we understand that the congruency statement is going to indicate what parts are going to be corresponding and congruent. Okay? All right, we reviewed this in class earlier. Okay, so just remember that we use these shortcuts to identify when two triangles are congruent. And just want to make sure that you understand that whenever we have two right triangles, then we got to check for the HL theorem. And the three conditions for the HL theorem is that the triangles must be right triangles, that the hypotenuse needs to be equal, and then at least one pair of legs will be equal. Okay, so that's what we reviewed today in class, so I'm not going over that. And then we also review mid segments, right? And you guys did very well on mid segments, so I don't think I have to review that either. Here real quick, the mid segment is always going to be half of the third side. And so if we know problem 27 that x is 34, we divide that by 2, and that's going to be AB. So if we have AB, that's going to be 17. So then we can set up this equation, 3x minus 1 equals 17, and we solve for x. Again, mid-segment is going to be 1/2 of the third parallel side to it. Okay, so I don't have to go over that either. Then we move on with the next topic, which is angle bisectors. And for angle bisectors, we are going to be having here that an angle bisector is going to bisect the angle in half. It's going to cut it in half. This is the angle bisector. So it's going to cut it in half, making these two parts equal to each other. So the question is asking us to find the measure of the angle ABD. So ABD is that half, one of those halves. So we're going to have to set up the equation. 6x minus 7 equals 9x minus 22. So we move the smallest x term, cancel the smallest x term, right? So negative 7 equals 3x minus 22 plus 22. So this is 3x equals 15. Divide by 3, and x equals 5. And don't forget, you still have to come back and substitute, right, into the angle ABD, which is 9 times 5 minus 22. So 9 times 5, we know it's going to be 45 minus 22. It'll give us 23. So that would be my answer right there. And then we moved on with triangle inequality theorem. And for triangle inequality theorem, we know that in order for us to say that 3 side lengths will form a triangle, we need to add the 2 smallest side, and that sum needs to be greater than the third one. So I explained this in class as well. So if we look at problem 14, the 2 smallest side is 8 and 12. So when I add 8 plus 12, that should be greater than my third side, 21. Which in this case is not, because 20 is not greater than 21, so we know that we cannot form a triangle with these side lengths. So then we have here 14, 10, and 6 for problem 16. So we need to make sure that we add the 2 smallest sides once again. So 10 plus 6, that should be greater than 14. Is 16 greater than 14? Our answer is yes. So because this inequality is true, then yes, we can form a triangle. Then on that same topic, we learn that when you're giving 2 sides, you gotta find the possible range for the values of that missing side, right? That will form a triangle. So then looking at this one, we have a triangle right here with side length 7 and 6. So we need to know what would be the possible value for that third side. So you have to write an inequality. And I told you to find the lower limit, you gotta subtract, okay? Subtract the 2 given sides. So 7 minus 6, that's gonna give me 1. To find the upper limit, we gotta add the 2 given sides. So 7 plus 6, and that's gonna give me 13. So then that inequality, compound inequality, will be the possible values for your third side. So what does this mean? It means that the third side can be 2, it can be 3, it can be 4, it can be 12, but it cannot be 13 and it cannot be 1, okay? So for problem 20, same thing. I'm just gonna write down my inequality. 12 minus 11 is gonna give me 1, and 12 plus 11 is gonna give me 23. And that's my inequality. Those are the possible values for my third missing side. And then we talked about the centers of the triangle. So here we're just gonna complete these sentences, which we didn't get to finish in class. So it says here, the 3 blank blank of the sides of a triangle intersect at the circumcenter. So this is a circumcenter. We know that the 3 perpendicular bisectors are going to be intersecting at the circumcenter, okay? And then the 3 blank blank of the angles of a triangle intersect at the incenter. So the incenter will be the point of concurrency for the angle bisectors. So here we have to understand that the angle bisectors, when they intersect, they're gonna meet at the point called incenter. For the centroid is the point, the intersecting point of all the medians in a triangle. The orthocenter is going to be the intercepting point of all the altitudes. And then this is super important and you must know for the exam. We know that here, one of these points will be equidistant from the vertices of the triangle. And that point will be the circumcenter, okay? So the circumcenter has to be equidistant from the vertices of the triangle. So I'm going to go ahead and type in here or write it here, circumcenter. Okay? And then we also know that there's a point, there's a center of the triangle that will be equidistant from the sides. And that would be the incenter. Okay? So the incenter, it's the point that is equidistant from the sides. So this is equidistant from sides. And then this is equidistant from vertices. Super important that you know that. Okay, so looking at this one, we're going to go ahead and determine what kind of centers are going to be shown in each diagram. So here we notice that we have angle bisectors. If we look at our diagram, right, we notice that the angle bisectors are formed by the incenter. In the next one, we're giving the altitudes. So these altitudes are formed by the orthocenter. And then the next one is, these will be called the medians. And the medians are going to be intersecting at the centroid. So this center is the centroid. And then my last center, I notice that I'm giving the perpendicular bisectors. So this center right here will be the circumcenter. Now there's one more thing that I gotta review with you guys, which is the hinge theorem. And that is that there's only one question on the exam about the hinge theorem. And I feel like a lot of you guys were struggling with this topic. So I want to make sure that I go over these once again. So it says here, write an inequality to describe the possible values of x. So here we notice that x is going to be in this expression that represents the angle DAB. So I want you to keep in mind that for any angle inside a triangle, that angle must be greater than 0, but it has to be less than 180 degrees, okay? So looking at that, keeping that in mind, that any angle in a triangle has to be greater than 0 and less than 180 degrees, that's how we're gonna be finding our inequalities, okay? To find the possible values for x. So right now, based on this, we can apply the hinge theorem and look at the opposite sides to determine which angle will be greater. So here we know that 2x minus 3, we're looking for the range, right? So 2x minus 3 is gonna be less than 31 because 2x minus 3 is opposite the side length 9 and 31 is opposite the side length 12. So 9 is less than 12. So that's why 2x minus 3 has to be less than 31. So 31 will be on my upper limit. But then what did I say here? That the angle has to be less than 180, which in this particular case will be less than 31. But we know that it has to be greater than 0. So 0 will be my lower limit. So let's go ahead and solve this. This is a compound inequality right here, what you have here. So we have to separate them. To find my upper limit, I'm going to go ahead and get this part right now. 2x minus 3 less than 31. And to get my lower limit, I'm going to be getting this part right here. which is 0, less than 2x minus 3. So 2x minus 3 has to be greater than 0. And then you solve these inequalities, right? So you would do plus 3. So this would be 2x has to be less than 34. And then divide by 2, and x has to be less than 17. That's your upper limit. And for your lower limit, plus 3. So this is 3. 2x has to be greater than 3, and divide by 2. So here x has to be greater than 3/2. So that's how you're going to be finding your final range for the possible values of x. We said the lower limit is 3/2 and the upper limit is 17. And that's how you get that. Okay, so let me try this again. I'm not going to solve it all the way through, but I'm going to be setting up the inequalities that I need to solve in order for me to find that compound inequality that shows the possible values of x. So first than anything, what we have to do, here it goes again, so pay attention. We know that we're going to be dealing with 3x minus 9. So we got to find if 3x minus 9 will be less than 36 or greater than 36. And what we use is we look at the opposite sides. So because 3x minus 9 is opposite to the side length 9, then 3x minus 9 has to be less than 36. So 36 will be my upper bound. But then I know that this angle right here, 3x minus 9, has to be greater than 0. So that's going to be my lower bound. So then what I do here is I separate this inequality, compound inequality, into two different ones. So my upper limit is 3x minus 9 less than 36. And for my lower limit, I use the second part of my compound inequality, 3x minus 9 has to be greater than 0. And then you solve, okay? But notice, it's not always going to be that 0 that you're going to be using, right? Let's look at this one right now. We got to find here the possible values of x. So once again, we got to recall that for any angle inside a triangle, it has to be greater than 0 and it has to be less than 180. So the angle with the expression is 3x minus 4. So we put 3x minus 4 and my compound inequality, right? So we got to find the upper limit and the lower limit. So 3x minus 4, is it going to be greater than 38 or less than 38? Well, based on the side lengths, I know that 3x minus 4 has to be greater than 38. So 38 is my lower limit right now because 3x minus 4 has to be bigger than 38. But if you keep in mind that angle has to be, if it has to be greater than 38, it has to be less than 180 degrees. Very good. So now we separate this compound inequality. My upper limit is 3x minus 4. To find it, I have to use this inequality, less than 180. And then my lower limit is going to be 3x has to be less than 38. So that's how you set up the upper limit and the lower limit inequalities. And then you solve those to finally give me the compound inequality for the possible values of x. Let's see if you understand once again. I'm going to go ahead and find the inequalities here. So we have 7n plus 5. And I got to decide, is 7x plus 5 going to be greater than 47 or less than 47? So based on the opposite side lengths, I know that 7n plus 5 has to be bigger than 47. So that 47 becomes my lower limit. But then once again, 7n plus 5 is my angle, and I know that it has to be less than 180. Once again, we separate the compound inequality. So this is 7n plus 5 less than 180. And we have we have here that 7n plus 5 has to be less than 47. Okay, so very important that you know how to set up that compound inequality and when to decide if you're going to be using the 180 or the 0. Okay, I hope that this video was helpful to you guys. You can review this video and then I will be posting the completed study guide, and then you're gonna be expected to complete your exit ticket, and that's it. I'll see you guys tomorrow for the exam.